Hello everyone, hope you all are doing well. In this video, we'll discuss the last problem of Leetcode Weekly Contest 305. It's a medium level problem. Yes, it's not a hard one. And in fact, I also feel the same. Relatively easier than the other hard problems that you have in the contest, right? The problem name is longest ideal subsequence. So you're given a string consisting of lowercase letters and an integer k. Now we call a string T ideal if the following conditions are satisfied. T is a subsequence of string S and the absolute difference in the alphabet order of every two adjacent letters in T is less than or equal to K, right? We'll see that in the diagram. Return the length of the longest ideal string. A subsequence is a string that can be derived from another string by deleting some or no characters without changing the order of the remaining characters. So we all know what a subsequence is. You take the string, delete zero or more characters from that string. The new string that you get is a subsequence of the original string, right? Note that the alphabetical order is not cyclic. For example, the absolute difference in the alphabets of A and Z is 25, not 1. So yeah, don't do that cyclic operations. That's what the problem is telling us explicitly, right? Let's take the example and jump into the solution. Let me just pull the code as well. Yeah. So yeah, let's jump into the solution. So let me take the first example. So the first example is ACFG BD and K equals to 2, right? So the problem is saying you are given a string, right? You are given a string. Now I need to get a new subsequence. Now for this string itself can be a subsequence, right? We delete no character from here and we get a new string, that is also a subsequence. Or we can delete some characters, like for example, if I delete C, it becomes A, B, G, B, D. I can delete more characters. So there are a number of subsequence that we can get. Now it is saying that there are certain conditions that needs to be satisfied. What are those conditions? The conditions are the subsequence that you are getting now. So for every two adjacent characters, like for example, if I consider this subsequence, so it's what are the adjacent characters? A and F, F and G, G and B, B and D. So the difference between the ASCII codes, just to simplify it, the difference between the ASCII codes of these two characters should be less than or equal to K. Now what do we mean by that? Forget about ASCII code. Suppose I assign 0 to A or 1. Let's assign it 1. B has 2 dot dot dot. Z has 26, right? So it says that suppose you consider A and C. So this has a value of 1. This is a value of 3. What is the difference between these two? It's 3 minus 1. That is 2. So this difference should be less than equal to K. K is given in the problem, right? So you need to obtain a subsequence which follows this condition that every two adjacent characters, the difference between the values of those characters, right, should be less than equal to K. This is known as the alphabetical order, actually. Alphabetical order, right? So this is what the problem says. Now actually you don't need to return the subsequence. You need to return the maximum length of a subsequence that you can obtain, right? Maximum length, no need to return the subsequence. So if I consider this example, so what will be the answer for this one? We have A, C, F, G, B, D and K equals to 2. So here I can have A, C, B, D, right? I delete these two, I get this. Now these two adjacent ones have a difference of less than equal to 2. These two have a difference of less than equal to 2. These two have difference of less than 2. I hope you can understand why the difference is less than 2, because this is having a value of 1, this is a value of 3, this is 2, this is 4, right? So 3 minus 1 less than equal to 2. 2 minus 3, again the absolute difference is 1, and similarly 4 minus 2, right? So we return 4 in this case because the length of this subsequence is 4. So we need to return the maximum length, right? Let me take another example. So the second example given in the problem is A, B, C, D, K equals to 3. So you can say, you can see we can take the whole string and we can return answer as 4. Why? Because obviously the difference between adjacent characters is less than equal to 3, right? And we are good to go. So again, I think the problem setters are really fond of dynamic programming. That is why they have given a couple of problems related to dynamic programming in the contest, the fourth and the third one. So I would say a traditional DP problem. Why a traditional DP problem? Because again, so you have 26 possibilities. You can have 26 characters, right? You can have 26 characters. Now, here also, what we can do, if somehow we know that uh, till position I, suppose I consider position I, so till position I, what was the maximum length of subsequence that I got? Okay, till position I, what was the maximum length of any subsequence that I got which was ending with a character C, right? How many possible characters are there? 26, right? If I calculate that, what is the maximum length of subsequence that is ending with all these 26 characters, then we are good to go, right? Then we are good to go. So what we can do, how we can save the state? We can do something like dp of, let's take current character. I'm just taking a name, which means length of longest ideal, right, subsequence ending with character, ending with char. This and this are same, right? dp of current char represent the length of the longest ideal subsequence ending with current char, right? Now what we can do, if I have this data, what I can do? So I can obviously iterate the whole string. I can iterate the whole string that is given in this case is, and we can see that how C can be the next character, how I can get the value of current character. So what I can do, if I want to calculate the value of current character, then just see, actually it will be a valid subsequence only if the alphabetical position of this current character, suppose that is I. Suppose that is I. So what are the possible values that I can have here? It can be I minus k, and the maximum value can be I plus k, right? These are the possible values that I can have, right? That means if the current alphabetical order, suppose I am calculating dp of char. So for dp of char, what I'll do, I'll calculate all the dp, all the answers that I've calculated for I minus k and I plus k. Because if the current character is C, let's take it with a concrete example. Suppose it is C and k is given to be 2, right? So here what I can have, suppose it is C, so I can have the value of C is 3, alphabetical, right? 3. So I can have a value from 3 minus 2 to 3 plus 2. Of these are the values of the characters that I can have adjacently, right? So that means 3 minus 2 is 1. So I can have 1 comma 2, the characters having alphabetical order 1 comma 2, and 4 comma 5, right? 4 comma 5. So that means here I can have A, I can have B, right? I can also have D, I can also have E, right? Because the difference can be a max of k, right? So if the current character is having the alphabetical order I, right? So I can place which characters which have alphabetical order in the range, and that is I minus k and I plus k. These are the alphabetical orders that will be valid, right? So yeah, that is the gist of the problem. So finally what will happen, dp of I equals to max of dp of I minus k, dp of I minus k plus 1 dot dp of I plus k plus 1, right? This will be the answer, dp of I, right? And obviously we return the max of dp. We traverse all the possible characters. We can have 26, so we traverse dp of A, dp of B, dp of C till Z, and we return the maximum answer. So yeah, this is the gist of the problem. If you feel that some part is not clear, please you can just watch the video again. It will be clear. Nothing too much fancy here. Let's jump into the code. Okay, we have taken the example. We have understood why we need to traverse within a range. The reason being, I need to consider only the valid characters. And what will be the valid characters? It will be current character minus k positions plus k position. What are positions here? Positions are the alphabetical order in the English dictionary, right? So yeah, let's look into the code. I've taken a dp array of 150. Why I've taken is because obviously for small characters the ASCII code is 97 to 122. So just for simplicity, and obviously the k can go up to 25, so that means 122 plus 25, that goes up to 147. So for simplicity I've taken 150. Now I start traversing the array. So I've started traversing each and every character on line number 7. Now I calculate what is the current max length. Why I've calculated it? So that I can assign it to dp of I, right? We'll see that on line number 11. And then the current character is I. Now as I told you on line number 9 we are doing it. So j equals to I minus k, and j is less than equal to I plus k, j plus plus. Consider all the possible adjacent characters that you can place for the current character, right? So now current max length will be dp of j for all the possible values of j for all the possible characters that you can place at adjacent positions plus 1. You get the current max length for the current character, right? Now you assign it to dp of I, and obviously you calculate the the maximum value of your answer, right? So yeah, pretty, I would say not too much to code, but yeah, the logic was, if you are familiar with dp, then I would say, I won't say it's an easy problem, but yeah, a typical dynamic programming problem. Need to see how to basically come up with what I'll store for the ith position, and then we are good to go. So generally what I've found is, just an extra point, what I found is, the length of the string is 10 raised to the power 5. And again, in questions where you need to deal with the english characters now, so try to see whether you can explore all the possible characters or not, because you have 26 characters, right? In most of the problem it says you having lowercase english characters. So we have 26 english characters. So don't just try to go to the most optimal solution on the first go. See whether is it possible that I traverse the array multiple times, and that multiple times can be the number of characters that I have in the problem. Here the number of possible characters are 26, right? That can also lead to a solution here. That is what we are seeing, right? Here k equals to 25. So what I can do, I am, for every position, for every character I, the total number of characters can be, the length of the string can be 10 raised to the power 5. And for every character, what I'm doing, I'm traversing the array for I minus k to I plus k. And what can be the maximum values? It can go up to 50. So the maximum complexity will be O of 50 into length, right? So that comes out to be big O of n only. So yeah, so this approach really helps in most of the problems, right? So yeah, hope you learned something new from this video. Do support it by giving up a thumbs up. Do subscribe to the channel. Also, if you have any questions, please do mention that into the comments. I'll try to resolve each one of them. Thank you. Take care. Bye bye.